The boiler feed pump and associated eccentric and strap will make a nice change from the recent focus on valve gear. As we can see, the feed pump is quite a complex part and is made up from a number of subcomponents. The pump body, the gland, inlet elbow, delivery union, bore retainer, and of course the ram. I'm going to use a set of castings from Reeves which comes as 3 parts: the main body, the gland and the eccentric. But we'll come back to the latter in a later video. The castings do look a bit crusty to start, but a bit of work with some files to remove the various bits of flashing and they do start to look a lot better. Both the pump body and the gland come with a stub for turning, so on both parts they need to be made round and at least approximately centred. For the pump body I do this by eye, by checking between the tip of the tool and the approximate centre of each side of the base. I'm not looking for perfection here, as I will recentre the part after I've swapped it around in the forejaw. When I'm happy, I turn down the stub. The diameter being irrelevant, I just need it round and the skin of the casting removed. After swapping the body around so that the stub is held in the forejaw, I take the same approach to centre it, but this time I'm working off the flange for the gland. Once centred, I get on and face off the end. I am turning the body down to 1 millimetre or so over length to leave some material to clean off the other end, which will be the base. Next I centre drill and drill as usual, working my way up through increasing drill sizes. The more I work with phosphor bronze, the less I enjoy drilling into it, as it's so very grabby, as I beautifully demonstrate here. Well, that was no real surprise. The more annoying thing here is that the prevention really is quite simple. Nigel, on his Go Create Hobby Machine Shop YouTube channel, explained this very nicely in one of his videos, but unfortunately I can't remember which, so instead I'll refer you to a video by Chris at ClickSpring, who also gives an explanation in a dedicated video. I'll include a link down below. I dig out an old box of drills and make the required modifications. It's not really visible on this drill, but the tip now has a 0 rake. Luckily I am able to rescue the part and get back to drilling to just under bore size and then reaming accordingly. This end of the pump needs to be counterbored for the gland, which is a simple boring job. And as I get close to dimension, I use a bit of 1/2 inch silver steel as a go-no-go gauge. To face off the base I turn a mandrel, the bulk of it being the same diameter as the bore of the pump, with a very slight taper just before the shoulder for the counterbore. A couple of taps with a soft hammer is enough to seat it nicely, and as the cutting force is towards the chuck and the cuts are not too deep, it holds firm as I face it off to length. By mounting the same mandrel in a collet block in the milling machine, I move on to bring in the base into dimension. I have modified the mandrel by drilling and tapping an M5 threaded hole down the centre to allow me to clamp the pump body in place. As the casting is quite rough, I line it up by eye using a square against each of the long sides. This is a precarious operation, as we all now know how grabby phosphor bronze can be, and I have not removed the rake from this slot drill, so I take multiple fine cuts to bring both the long sides in. As I said earlier, the casting is slightly undersized for Don's design, so I'm just looking for a pair of clean and parallel sides. I do likewise across the shorter sides, but in this dimension the casting is quite a bit oversized for Don's design and will need bringing in later. The big advantage with this approach is that by cutting each pair of sides to the same depth on the quill, I can be confident that they are equidistant from the bore, which will make setting up easier later on. As I know the bore is centred between the sides of the base, finding the centre of it is a simple job and allows me to quickly drill and tap the 6 6BA mounting holes. Rather than delve down to the bottom of the vise with the edge finder, I use a disc tool in the wriggler to find the centre of the bore and use this for the 7BA gland bolts. The wiggler is a bit more fiddly to use and also means I have to drop the speed, which of course on this mill means messing around with the belts. For these smaller drills I'm not removing the rake. I do find that it's the larger diameter drills that grab. The outlet on the delivery side of the pump is complex. From this side I need to drill through to the bore at 3.2mm, then counterbore for a depth of 9.5mm at quarter by 40 TPI tapping size, which in my world is 5.6mm. However, the counterbore needs to have a flat bottom, so I grind the end of a 5.6mm drill flat and also remove the rake on the cutting surface. But unfortunately this does not work. So I drop down to a smaller drill, grind it flat, but this time I don't remove the rake. This also does not work, but I continue with modifying the drill bit and end up using a diamond file to put a slight rake on the back of the cutting faces, and I eventually succeed. It's still tough going and I'm having to put a lot of pressure on the large drill to get it to cut, but I do get down to depth in the end. And then with the counterbore drilled, I cut the thread to a depth of 4.75mm or thereabouts. This threaded section is for the ball retainer, which I'll cover off in the next video. Perpendicular to the section I have just machined is the outlet port to the boiler feed. After repositioning the pump body in the vise and armed with my learnings for flat bottom drills, it's a relatively easy job to drill and tap. It's probably worth calling out that I'm touching the drills off against the bottom of the vise as a reference for the depth of cut. This port is tapped at 732 by 40 TPI, and as we can see it's very close to the main body of the pump, so I may need to machine that back when I come to fit the union. Machining the inlet port is a repeat of the first section of the outlet port. There is, however, a complication. There is a small detail on Don's drawing, which for now I am assuming is a slot to allow the water to be drawn into the pump body around the ball that will form the check valve within the inlet port. But until I'm certain, I'm going to hold off on cutting that slot, and first I need to get some stainless steel balls. As for this other little detail, I have no idea. But if anyone does know, please do feel free to explain down in the comments. I did say at the beginning of this video that making the boiler feed pump was going to be more interesting than the seemingly endless parts of the valve gear that I've been working on recently, and it has certainly proven to be so. Not only that, but I've had to learn some new techniques along the way and still have some unknowns to deal with. Hopefully I'll get those resolved so that we can see a completed and working pump in the next video. Thanks for watching.